Hi there, welcome back to Universe Intelligence, dear science explorers. Are you ready for another mind-bending adventure? Yes? Let's go! The cosmos, vast and mysterious. What secrets does it hold? For centuries we have gazed at the stars, asking ourselves these questions. And now, on the horizon of scientific exploration, a new concept emerges, that of parallel universes. Imagine a reality where every possible outcome exists, a reality where infinite versions of ourselves live countless different lives. This is the fascinating promise of the multiverse. But is it real, or is it just a figment of our imagination? Let's embark on a journey to discover the amazing world of the multiverse. Our journey begins with a simple question. What if our universe is not alone? What if, beyond the veil of our perception, countless other universes exist? Each with its own physical laws, its own history, its own destiny. In the realm of quantum mechanics, the rules of classical physics collapse. Particles exist in a state of superposition, occupying multiple states simultaneously. But what happens to the other possibilities? Do they simply vanish? In the 1950s, a young physicist named Hugh Everett III dared to explore these questions. He proposed a radical idea that would challenge the very foundations of physics. Everett's theory, known as the many worlds interpretation, suggests that every quantum measurement generates a new universe. Imagine flipping a coin. In our universe, the coin lands on heads, but in another universe, born at the moment of the toss, the coin lands on tails. Every possible outcome of every quantum event is realized in some universe. This is the essence of Everett's multiverse, a realm of infinite branching realities. Everett's theory was met with skepticism and even ridicule, but Everett persisted, believing that his theory offered the most elegant explanation for the strange behavior of quantum mechanics. Over time, Everett's ideas began to gain traction. The idea of the multiverse, once considered outlandish, began to seem more plausible. To understand the multiverse, we must first delve into the strange and wonderful world of quantum mechanics. This is the realm of the infinitely small, where the laws of classical physics no longer apply. In the quantum world, particles behave like waves, spreading out in space and time. They exist in a state of superposition, occupying multiple states simultaneously. One of the most famous examples of this is the double-slit experiment. In this experiment, electrons are fired at a screen with two slits. Instead of passing through one slit or the other, the electrons pass through both slits simultaneously. This is because the electron exists as a wave, spread out in space. But here's where things get even stranger. If we try to observe which slit the electron goes through, the interference pattern disappears. The act of observing collapses the wave function, forcing the electron to choose one path or the other. This is known as wave function collapse. The double-slit experiment highlights the bizarre nature of quantum mechanics. According to the many worlds interpretation, all those possibilities continue to exist. Every time a quantum measurement is made, the universe splits into multiple universes, one for each possible outcome. In one universe, the electron passes through the left slit. In another, it passes through the right slit. The cosmic microwave background, or CMB, is a faint afterglow of the Big Bang. It is a snapshot of the universe as it was just 380,000 years after the Big Bang. The CMB is incredibly uniform with the same temperature in all directions. However, there are tiny fluctuations in the temperature of the CMB. Some physicists believe that these fluctuations could be evidence of other universes. They suggest that collisions between our universe and other universes may have created these fluctuations. If we could find definitive evidence of collisions with other universes in the CMB, it would be a game changer in our understanding of the multiverse. Section 5. Brain worlds, when universes collide. Imagine for a moment a loaf of bread. Each slice of bread represents a universe. These universes are separated by a higher dimensional space called the bulk. This is the idea behind brain worlds, a theory that suggests that our universe is just one of many three-dimensional brains floating in a higher dimensional space. According to brain world theory, these brains can interact with each other through gravity. Some physicists believe that the Big Bang itself was caused by a collision between two brains. These collisions could be incredibly violent, creating ripples in space-time and potentially spawning new universes. Section 6. Theanthropic Principle, Fine-Tuning, and the Multiverse. Our universe is an incredibly fine-tuned place. The The fundamental constants of nature, such as the strength of gravity and the mass of the electron, seem to be perfectly calibrated for the existence of life. If these constants were even slightly different, the universe would be a very different place. This apparent fine-tuning has led some physicists to invoke the Theanthropic Principle. This principle states that the universe must be compatible with the existence of observers. Otherwise, we wouldn't be here to observe it. The multiverse offers a possible explanation for the Theanthropic Principle. If there are an infinite number of universes, each with its own set of fundamental constants, then it is not surprising that we find ourselves in a universe that is fine-tuned for life. After all, if our universe were not fine-tuned for life, we wouldn't be here to ask the question. Although the Theanthropic Principle is a controversial idea, it is a fascinating possibility that could explain one of the deepest mysteries of our existence. Section 7. Inflationary Theory, the Genesis of Multiverses. In the first fraction of a second after the Big Bang, the universe underwent a period of exponential expansion known as inflation. During inflation, the universe expanded faster than the speed of light, growing from a size smaller than an atom to a size larger than our observable universe today. Inflationary theory was originally proposed to solve some of the problems with the standard Big Bang model. According to some models of inflation, known as eternal inflation, the process of inflation never really ends. Instead, it continues in different regions of space-time, creating new universes all the time. Eternal inflation provides a natural mechanism for the creation of a multiverse. Section 8. The Many Worlds Interpretation, Infinite Branching Realities. The Many Worlds Interpretation, or MWI, suggests that every quantum measurement causes the universe to split into multiple universes, one for each possible outcome. This means that there are an infinite number of parallel universes, each representing a different path that history could have taken. For example, imagine you have to make a choice: eat a cookie or don't eat a cookie. According to the MWI, both choices are realized. In one universe, you eat the cookie. In another universe, you don't. The MWI is a controversial interpretation of quantum mechanics. However, it is a fascinating possibility that challenges our very notion of reality. If the MWI is correct, then our lives are far stranger and more complex than we ever imagined. Okay then. Conclusion. The ever-expanding frontier. The multiverse is a captivating concept that has captured the imaginations of scientists and philosophers alike. While we may never be able to definitively prove the existence of other universes, the evidence is mounting. From the strange behavior of quantum mechanics to the echoes of the Big Bang, there are hints of the multiverse all around us. The search for the multiverse is a testament to the power of human curiosity. The more we learn about the universe, the more amazing it becomes.